Hi, so we have a problem from section 7.1 that talks about trigonometric substitution. So the directions say, use the given substitution to express the given radical expression as a trigonometric function without radicals. Assume that your angle is between 0 to pi over 2 or 0 to 90 degrees. Then find the expressions for the indicated trigonometric functions. So what we're going to do, we're going to let x equal 7 times the secant of theta in the square root of x squared minus 49. Then we're asked to find what the values are for our sine and cosine of our angle. So here, we're going to make our substitution. We're going to set the square root of x squared minus 49 equals to the square root of 7 times secant of theta squared minus 49. In other words, over here on the over here on the right side, we're going to substitute x equals 7 secant of theta into the x squared part. Okay, so that's what we have over here on the right side. So all the action right now is going to happen on the right side. So let's do some algebra. So on the inside of that radical, we now have 7 squared, which is 49, secant of theta squared, which is secant squared theta, and still minus the 49. Now, bring it down. Over on the right side, we now have a 49 in common with each of those terms. So if we factor out a 49, what we have left with is a secant squared theta minus 1. Okay? Now, what we can do here, we can do this one of two ways. We can actually use a Pythagorean identity, and I'm going to write it off to the side here. 1 plus tangent squared theta equals secant squared theta. So if we algebraically manipulate that, basically if we subtract the 1 to the other side, then we have a new identity, tangent of theta equals secant squared theta minus 1. So secant squared theta minus 1 would actually go in place of our secant squared theta minus 1 would actually be replaced with tangent squared theta. So in other words, we now have the square root of 49 times tangent squared of theta. Because secant squared theta minus 1 was equal to tangent squared theta. And it all comes from this identity that we should be familiar with. Okay, so let me bring down my information. Now over here on the right side, the square root of 49 tangent squared theta, you can break this up into two parts and say the square root of 49 times the square root of tangent squared theta. Or we can just go ahead and say the square root of 49 is 7, and the square root of tangent squared theta is just 7 tangent of theta. It gets rid of the square on the tangent function. So now we can actually solve for tangent of theta. So if we divide both sides by 7, we now have the square root of x squared minus 49 divided by 7 equals tan of theta. Alrighty. So now what we have to do, we've got it to where it's one of those three basic trig functions. Now we have to figure out what our sine and cosine values are. So since our angle is in the first quadrant because it's from 0 to pi over 2, we can now set up our triangle. Okay, so if we remember from the definition of sine, cosine, tangent, specifically tangent, our tangent values are opposite over adjacent. So in this case, x squared minus 49, the square root, is our opposite side, and your adjacent is 7. But in order to find sine and cosine, we've got to figure out what the hypotenuse is. So this is when we have to do Pythagorean Theorem. All right, so we have c squared equals 7 squared plus the square root of x squared minus 49 squared. All right, so 7 squared, that would be 49, plus, well, the square root of x squared minus 49 is just x squared minus 49. It just gets rid of that square root. So now, clean it up. 49 minus 49, well, those guys cancel out. So all we're left with is c squared equals x squared. Now remember, in order to solve for hypotenuse, we've got to take the square root on both sides. So that means your hypotenuse is going to be x, just plain old x. All right, so let's go back up to our triangle, and we're going to list our triangle with the hypotenuse of x. So now let's figure out what the sine and cosine values are. So I'm going to write this in different colors. So your sine of theta, well, remember, your sine is your opposite over hypotenuse. So this would be the square root of x squared minus 49 divided by x. Okay, there's your sine value. And your cosine value is your adjacent over your hypotenuse. So our adjacent side from our triangle would be 7, and your hypotenuse from the triangle would be x. And these would be your final answers.